Okay, can you see my presentation?
Yeah, so we can see it.
Yeah. So, good afternoon, all of you. So, initially, I will give my introduction. So, myself, Deepak Pawar. Currently, I am working as a data scientist in Collabora Digital. So, I am having total, I completed my graduation in electronics and telecommunication. I also completed my post graduation in ANTC. Then, I worked as assistant professor for around 12 years. And then, uh, from last 3.5 years, I was working as a data scientist. I work with the Cognizant, and currently, I am working with the Collabora Digital. So we'll start with this subject. So the subject which was I'm going to teach you, it is nothing but the data science subject. So this subject is having around, I think, 6 units. So we'll try to cover the units one by one. And I think in the first week of September you will be having your this in same exam. So we'll try to complete 2 units before that, and then remaining part we'll see after that. So the first unit itself is a introduction to data science. If you ask me, this unit is entirely as such a completely theoretical unit. We'll try to see what are the parts available inside this unit. The entire syllabus available for this unit is divided in some parts. So initially we are going to see what is the definition of data science, then what is a big data, then how we are trying to correlate big data with the data science. Second part we have it is the recognizing the different types of data which is available. And again, the data types are, we have the different data types based on the different what you can say classes, or different based on the different applications. So we'll try to see that part. Then we'll see the process of the data science. What is the process of data science, the way by which the data science project is handled in industry, and what are the different steps are coming inside that. This is next part we have. And at the last we'll see what is the machine learning, its definition, and how we are trying to correlate the machine learning with the data science. So as if you see, the unit is quite small one, but the what you can say, the theoretical part which is available inside this is having a vast range. So we'll try to cover that entire stuff. uh, Out of you, how many are from the, or those who are having the coding background, or those who are from IT computer, or all the students are from computer and IT department? Because I came to know it is, I think, what is it, honors subject, right? Yes. Hello. Hello.
So all of us are from different departments. Some are from IT comp and others from core branches.
Okay. Can you see my presentation? Are you sync with the syllabus slide?
Not the syllabus, just the first title page of the presentation of Unit 1 Introduction to Data Science.
Okay, just a moment, just share the screen. Can you see the entire slide?
Yes, sir.
Okay. Yeah, so I was explaining about the different parts available inside this unit. So we are going to see the definition of data science, big data. Then we'll see the different data types available for us, as well as the what you can say, the insights of the data science process. And at the last we'll see machine learning definition and relation of the machine learning with the data science. So you all are from different department, right? Yes or no?
Yes, all from different departments.
Right. So, can I ask one small question? If one or two students can give me the answer, why you have decided to go for this subject as an honor subject? I think this is as an elective subject, right? You might be having some other options for honor also, right? Yes. Hello.
We went, like most of us, I think we went for this data science as an honors course because being from a core branch myself, I wanted to see what kind of opportunities I have if I were to delve into the IT sector.
Okay.
So
ठीक
I
है.
thought maybe this will give me some base if I were to go there.
Okay, okay, ठीक है, good. So currently, actually, the because now we have to see what is the data science. So we have to go for the definition of data science. So as we are saying, as I was asking you that are you all from the same department, or are you all from the computer department, or from some other department? The thing behind that is currently whatever the scene is available related with the data science, I think you might have heard currently we have the entire boom which is available with respect to what you can say IT sector is related with the data science, and that to be from last around 1.5 per year the boom is there for Gen AI. I think you might have heard about this, right? So that to be now this Gen AI is again one of the what you can say subfield available for data science. But now when we are talking about a data science is not about everything which is related with the IT department. So here we are having the interdisciplinary part. The things which is interested with the data science is the interdisciplinary, means when you are dealing with any project available with this, as we are broadly we are saying it is coming inside what you can say the IT part, or we can say it as a computer part or the programming part, but it's not the case. At the end, if you go inside the data science project, then there we require the people from the different department. Like we require the people from math department also, where we have to deal with the statistics part. We require people from the different department. Like suppose I am dealing with the e-commerce project, so at that time e-commerce project, or when I am dealing with the financial project, at that in that finance project I required some of my team member which we are calling it as a domain expert. This domain expert, they are again from the commerce department. So in this way we are seeing it as a this data science is an interdisciplinary field in which basically what we are trying to do here, we are trying to deal with the data, whatever the data which is available with us, we are trying to deal with that data, we are trying to analyze that data, and from that data we are at the end we are trying to get some meaningful information. So in short, this is the definition available for your data science. If I want to say, just a moment. Yes, so I think you might be going to read this slide. So this is the basic definition available with the data science. So we'll go through this definition in a very proper way. It's very important to understand this definition. So what we are saying related with the data science. So data science is an interdisciplinary field. The first word come is a interdisciplinary field. It's not like that. It is only dealing with the IT part. So we are having an interdisciplinary part. So it is interdisciplinary field that uses the different scientific methods, as well as it uses the different algorithm. For what purpose we are using it? So we are using it to extract the knowledge and insight from the structured and unstructured data. So these are the majority. We have these two types of data. When we are talking about the data comes in three different types: structured, unstructured, and semi-structured. The structured data, which data we are calling as structured data? Anyone is having any idea? You all are from, I think, third year department, right? So have you heard this word structured, unstructured data? Yes.
Structured means data arranged in the proper structures like tables.
Good. And unstructured means?
That means not in proper structure like files, text files.
Yes, exactly. So mostly, yes, it is a right explanation. So when we are talking about a structure, we are having some proper structure, like whatever he said, that we are having a structure in terms of rows and columns, or we are having a structure as a tables. And to deal with the structured data, majority we are using, I think you might have heard about this language, or you might have learned this language, SQL, structured query language, right? So this is the what you can say, we have a different what you can say servers, we have the different workbenches, all the stuff to deal with the structured data. But now the new data which is available with us is a unstructured data, and in this unstructured data all the remaining data comes. Currently we all are using a social media and all the stuff, and while when we are talking about the GenAI, so in GenAI basically we have to deal with the unstructured data. So as such we don't have any particular structure in unstructured data. Like if you see whatever the review we are writing for any product, so that review is unstructured data where we don't have a proper what you can say length for our data. One person can give the what you can say review for two words, one person can give a review for 200 words, so the length is get changed. Again, in unstructured data we have audio files, we have image file, as well as what you can say we have the files which we are saying it is a text file. So in this way we have the unstructured data, and one more data what you can say data type we have, that we are considered as a semi-structured. So we have some JSON file, XML file, those who are dealing with that. But majority work happens it related with the structured and unstructured data, and mostly most of the machine learning algorithm they are working with the structured data. So the definition of data science is an interdisciplinary field that uses the scientific methods and algorithms to extract the knowledge and insights from the structured and unstructured data. At the end, what it is doing, it is mentioned here, it combines the principles from mathematics, statistics, computer science, and this is again one important word, domain specific knowledge. See what happened as an academician, I was also academician when we are dealing with some of the concepts, when we are dealing with some of the algorithms, we are having a lack of this, because when we are going in industry, these two things, what we can say, academician as well as the industry, both should go in a combination, or both should help each other to go ahead. But the thing happens when we are dealing with the academic part, at that time we don't require the domain specific knowledge, but when we are dealing with the industry specific part, the domain knowledge plays a very important role. Without domain knowledge it's not possible to handle any project of what you can say industry. So we should have a person who is having a domain knowledge, right? Just now what we are saying, the data science field is used in different industry. We have e-commerce industry, we have health industry, we have a finance industry. In finance we can have a banking industry, we have an insurance industry, we have a life science projects. So different fields are there, so that's why we require a domain specific knowledge here. So when we are dealing with the data science, so we are combining the different principles from mathematics, then from statistics, as well as from computer science, as well as we are combining the principles from domain specific, the person who is having a domain specific knowledge. For what purpose we record all the stuff? To analyze the large data sets, as well as to understand the patterns available with our data. We have to understand the different patterns, and from that pattern, after understanding that pattern, the important part, which is the last part of your data science project, is nothing but we have to make certain decisions based on that. So in this way we are having these different problems. So at the end we can conclude this part. The data science is widely used in various industries to solve the complex problems. Then we have to predict some of the outcomes, as well as we are driving some of the innovations. So in this way we are having a definition of data science. So is it clear, or anyone is having any doubt inside it? The definition of data science is clear?
Yeah, no doubts.
Okay, can we go ahead? Yes. Okay, I will go ahead. Just yes, so in that way, whatever the definition we have seen, the first line is a multidisciplinary. So in this diagram, you can see where we have the data science. So data science here, we have it as a center, and data science, it requires the help of the different what you can say fields. Like here we have the statistics, then we have visualization. So at some point of time, we have to deal with some databases. Then we also having data mining, which is as good as our machine learning algorithm. Then we have some pattern recognition, then we also having a neurocomputing. So we have the different branches. That's why it is a multidisciplinary. An important part is we require the domain knowledge, at least for industry specific project. Without domain knowledge it's not possible to deal with what you can say to any data science project. And the same diagram we have in the different way. The data science, if you want to say, in data science we have we are having a different branches, like we have math, we have statistics, we have advanced computing part, visualization part, we have some scientific methods, we also in deals with the data engineering part, then we have some domain expertise, and lastly we have the hacker mindset. So by combining all this stuff we can go for any data science project. So this is the stuff related with the data science. Now this next part is a big data. So we have to correlate the data science part with the big data. Anyone gives the information about big data, or what you know about big data? Which data we are calling it as big data? Anyone is having any idea? And why this terminology is there, big data? Why not we are using a term as a data? Yes, you can tell it's not like that. Whatever the idea we have, we'll try to elaborate it. If you are not clear with this idea, then also we'll try to clear the idea, but speak something, otherwise this will be only the unidirectional lecture. I don't want that. So what is the big data? Which data we are calling it as a big data? Anyone knows?
Because unlike traditional data, when it comes to big data, it's too large to be dealt with.
Okay,
Like
so
there's
basically,
terabytes and terabytes of data.
right, so basically when you are talking about big data, you are talking about size, right? Yes.
Yes.
Right. So, see, yes, it is right. It's, I will not say it is 100% right, but yeah, around 60 to 70%, whatever the definition is there. Many times, when we are talking about the big data, we are talking about the size. But each and every time, size is not a parameter on which we are considering as a big data. The big data terminology, it is also depend on the complexity of the data which we are using. So big data, it is again depend on the time of a latency which we are using to access the data. So it is not only depend on size, but definitely size is an important issue. Because of size we require more time to access the data. Because of size the data becomes complex. So that is the case, but each and every time the big data word, it is not based on the size. We also have some of the parameters. So which parameters we have, that part we'll see now. This is the definition available related with the big data, and I'm considering this definition with respect to data science perspective. Actually, big data, this terminology, it comes in a part when we are talking about the what you can say, there is a concept of data engineer. Okay, just before going to see this, I will do one thing. Okay, I will give simply just a flow, the which different, what you can say, uh, positions are available when you will go in an industry. So the first important position in which we have the different jobs is called as a data analytics position. Then the second part where we are having a good opportunity, that is nothing but a data engineer. The third part, we have it as a, you can consider as a ML engineer, machine learning engineer. Yeah, you can consider it as a data scientist. Next, we have parts where we are dealing with the deployment, that we are calling it as ML ops. So in this way, majority, I'm saying majority, we have the different, what you can say, or some more positions in an industry. When we are talking about the data analytics, this data analytics, mostly they are dealing with the, what you can say, our data, which is available in SQL form, as well as they are mostly dealing with the visualization part. So when we are dealing with this visualization part, so currently in industry for visualization purpose, there are two important software they have. One is a Tableau and another one is a Power BI. So majority times data analytics has to deal with this part, as well as they also have to perform the EDA part, exploitative data analysis, where they require some knowledge of Python, or they require the knowledge of R language. So in this way we have the positions related with the data analytics part. Now second, we are talking about the data engineer part. They plays an important role. As such, data engineer, you may consider it as a part of a data science team, or you may consider it as an individual element, because in data engineer basically they are dealing with this terminology which we are calling as ETL, extract, transform and load. So this data engineer, they have majority works to access the data which is available from client, or what you can say, yes, from client to our end. So the entire process and all the different stuff, that is how to extract the data, how to transfer and how to load the data, this entire process is decided by this data engineer. They are using a different tools like Informatica. You might have heard this Informatica. So there are different tools are available. So this data engineer, they are dealing with this part, and then they are providing a data which might be in what you can say structured form. You can say that a .csv file, or you can say as a SQL workbench in that form, the data which is available in terms of tables and all the stuff. So in what you can say standard organization, they have the separate person, those who are called as a data engineer, whose entire responsibility is to managing, as well as he is going to manage the schema. Schema means the structure of the table, as well as the structure of the each and every what you can say column, you can say it as a field, like that. So the data engineer, it plays important role. Next is part is nothing but data scientist, or you can consider as a ML engineer. The important work available with them is nothing but to perform what you can say feature engineering part. After feature engineering, they have to design a model, they have to evaluate the model, and after evaluation of the model, they have to generate one executable file, and that executable file mostly it is hand over to the ML ops. It is called as machine learning operational, something like that. Okay? So ML ops, the work of this ML ops is whatever the file which is coming, executable file which is coming from this data scientist, they have to put it on what you can say cloud. So most of the time we are having 3 different clouds. You might be knowing which clouds we are using. You might be having Azure, you might be having AWS, or you might be having GCP. So it depends on what you can say industry to industry. These 3 clouds are get varied, and your what you can say executable file which is get loaded out of these 3 different clouds. They have their different services on which what you can say they are going to run whatever our executable file is there. So majority these 4 what you can say different parts or the different roles are available when we are talking about the data science industry, right? This part sometimes, many times now currently the thing is that industry is expecting all that every person knows all these 4 part, that you are considered as a full stack developer. So they everyone must know all this part. But as with respect to data science department, if you see most of the time data science department, they are dealing with the features, developing the models, evaluating the models, making the changes in your model, and try to get the good performance parameter. That is the main job of our data science engineer or data scientist, we can say it as. Is it clear? This part is clear? Yes.
Yes, it's clear.
Okay. So why I'm explaining this, because now I'm talking about a big data. So in that perspective, if you see the big data, this part it comes inside this data engineers part, big data. Anyone knows some of the what you can say different model what you can say tools we are using to deal with the big data? Have you heard this word Hadoop? Have you heard this word Apache Spark? Yes. So these are the two what you can say tools are available, those who are dealing with the big data, and these tools must be known to the data engineer. The important part is that, so the data engineer must know this how to deal with this big data, and to deal with this big data they must know these 2 tools, Hadoop tool and the Apache Spark tool. Okay? Yes. Just a moment. Yes, so we are talking about this, the definition. So what is the definition of big data? In the context of data science, the big data refers to the extremely large and complex data set that are beyond the capacity of the traditional data processing tools to capture the data, to store the data, and to manage the data, as well as to analyze the data efficiently. So in data science, basically big data is leveraged to understand the hidden patterns, then the correlation between different fields, and the insights that can be driven, that can drive the decision making, innovation, and the predictive analysis. Okay, it requires the advanced tools and techniques such as distributed computing, as well as we require some of the tools in machine learning also to handle and to extract the value from the massive data set. So that's why we are using this big data. Now, which data we are calling it as a big data? So when we are dealing with the big data, generally three V's are very, very important to understand related with the big data. The first V, it talks about just now whatever we say, that is about the volume or the size of the data which we are using. So currently we have the, what you can say, the data which is coming in a very huge amount. So we have the data from social media, as well as we have the data from sensors, we have the data from the bank transactions or our e-commerce transactions. So we have a huge amount of data. So the volume plays a very important role, and the volume is huge in case of a big data. Next is the velocity. Just now I explained about the latency. The data, as the data is huge, so the moment you are requesting the data and the moment you will get the data, the time between that we are considering as a latency. So if you have a huge data, the latency time is in that way is huge, so we have to reduce that time. So that's why velocity is also important. Velocity is nothing but accessing the information. That is the concern we have related with the velocity. Yes, next is a variety and the complexity. Just now we have seen. So as we have the complex data, why the data is complex? Because the data, we are, in case of big data, we are also dealing with structured, we are dealing with unstructured data, we are dealing with the semi-structured data, where we are dealing with the text, we are dealing with images, we are dealing with the videos. So in this way, these three V's are very important when we are talking about the big data, and because of this three V, currently we are dealing with the big data. So in this way, we are trying to correlate the connections between big data and the data science. Is it clear? Can you go ahead?
Yes,
Yes.
sir.
Okay. So just remember this 3V: volume, velocity, variety. Okay. Because of this three, the data becomes big. Okay. Okay. We'll go to the next part. Now, how to deal with the big data? So to deal with the big data, just now in this diagram also they have shown the same thing. Initially, what type of a data they were using, and currently whatever the data we have. So you go from inner side to the outer side. The data becomes more complex. The data becomes, the speed of data becomes less in this way. So initially, if you talk about the data velocity, the batch one is performing in the fastest way. Then we have the periodic data. After that, we are having near real-time data, and currently we have the real-time data. In this way, the velocity is get increased. Next, the data size. Initially, we are dealing with the KB, MB, GB, TB. Currently, we are dealing with the PB, petabyte of the data. And in the same way, we have the data variety, which was there initially. Most of the data we are having in terms of table form, but now we have the data as audio, video, wave, photo. Then we have social data, we have SMS. So different data we have. We are also accessing the data from, what you can say, the mobile app and all the stuff. So in this way, we are talking about the big data. Okay. So this is the concern related with the big data, which we must know as we are dealing with, what you can say, data science part. We are trying to have a correlation between big data with the data science part. So how to deal with the big data? So we require different tools. It's not that much easy to deal with the big data. So two tools I already explained you. One is a Hadoop tool, and the second one is Apache Spark. Both are in that way is an open source tool, and they are having the distributed computing inside it. So you might be knowing you have the centralized computing and the distributed computing. As we have the, what you can say, huge amount of data, so only a single computer is not sufficient to deal with the data. That's why we have the, what you can say, the computation part, it is in the distributed way. So we have a Hadoop, we have Apache Spark, we have Apache Flink. Different distributed computing parts are available, but Hadoop and Apache Spark, these two are quite popular one which we are using. Next, as we have huge data, so we have to store the data as well as we have to manage the data, right? So in case of what you can say, structured data, mostly we are dealing with the SQL databases, right? So in the same way, for unstructured data, we have this NoSQL databases. In NoSQL, MongoDB is quite popular database, but we are also using Cassandra and all the stuff, as well as we also have the Amazon S3. It is the S3 bucket we are calling it as. This bucket we are also using for storing purpose and managing our data. And currently with Google also provides a Google BigQuery. This Google BigQuery is as good as our SQL queries. We are also passing some SQL queries to deal with the data and to manage, as well as manage the data storage. So in this way we have this what you can say, data storage and management tools. Data processing and analysis, as we are dealing with the big data, again it's not that much easy to deal with the big data. We require certain advanced tools. So here we are using Apache Kafka. We are also using TensorFlow. This TensorFlow, it is coming from the basically machine learning side. This Apache Kafka, basically it comes in the real-time data pipelines. When we have to access the real-time data, we are using it. And we are also having one more library we are using, that is a DASK. So we have to deal with the big data. This new tools we also required in our case. And lastly, just now whatever we said, we required some data visualization part. Initially the data visualization we are doing it what you can say, in a EDA part itself, by using some standard library we have, that is matplotlib library, seaborn library. By using this we were doing the data visualization. But now day by day the data size is increasing, and as we are moving towards the big data, we require some special visualizations tools. So one of the visualization tool is a Tableau, one is a Power BI. Power BI is the tool by Microsoft, and we have the Plotly. This is a new library which is introduced in case of a Python, and the important work of this Plotly library is for visualization purpose. So in this way we have the stuff related with the big data. Okay, is it clear? So to deal with the big data, we have the distributed computing, we have the data storage and management, we have the data processing and analysis. This new tools we required, and lastly we required the data visualization tool. So we have to do certain modifications to deal with the what you can say, big data. Okay, is it clear? Yes, can we go ahead? Anyone is having any question, you can ask the question if you have the question.
Yeah, so we can go ahead.
Now we are moving towards the next part, which is nothing but, as per our syllabus, it is the recognizing the different types of data. So generally whatever the data we have, so this is the types of data. I am not talking about a data type. These are two different concerns, right? I think you might have deal with a Python somewhere in your first year. What are the different data types you are using in Python? Anyone gives in detail or in short which different data types you learn in Python? Yes.
There are strings, uh, integers, floats, and there are sets like dictionaries, lists, etc.
Exactly right. Very good. So we are using this we are acting as a data types. Now we are seeing the different types of data which we are using. So this data we are dividing in two part in general. First we are calling it as a qualitative data, and second part we are calling it as a quantitative data. When we are talking about a qualitative data, mostly this is considered as a categorical data. Anyone is having any idea about a categorical data? So here we mention in categorical data we have two types. One is a nominal data, another one is a ordinal data. So what is a nominal data? Yes, like suppose now you all are from MMCOU college. If I want to understand that corresponding student, right, if I want to go for its gender, right, so we have it as a M, or we have it as a male, or we have it as a female, right, male female, in this way. Now this data in this, which one is superior and which one is inferior, can you predict it? The thing is that just by understanding the person is a male or the person is female, we are unable to understand their orders, that male is important or female is not important, or female is important and male is not important. So the data where it's difficult to understand the order, these data types we are considering as what? Nominal data. Right, so right now we have the different colors, white color we have, black color we have. You can go for any example where the order is not important. White color is having the same importance as that of a black color. Green color again is having the same importance as that of white, black, and all the stuff. So that data we are considering as what? Nominal data. This nominal data, or the what you can say called the categorical data, it is again divided in two part. One is called as what you can say binary data, and one is called as a multivariate data. Now what is the meaning of binary and what is the meaning of multivariate? Now just now I have given the example of gender, male and female, right? Or whenever you are going for yes or no type of examples, right, whenever you are going for 1 or 0 type of examples. So this all the field they are coming inside the binary part. And when we are going for the multi-variable or multi-variable, so in multi-variable we have more than two category. Like now I told you about a color, so we have different colors there, right? So in this way we have the binary as well as a multi-variable data that come inside the nominal data. Next we are going inside it, the second part is available, that is ordinal data. In ordinal data, order plays an important role. What is the meaning of that? Now you all are dealing with your what you can say, as a student you are dealing with your marks, so you all be having a CGPA part. In CGPA you might be knowing, some of you might be having distinction, some of you might be having first class, some of you might be having a second class, some of you might be pass, or some of you might be having a back, some of you might be failed, or what you can say, those who are X. Now in this case, if you see, if I am providing this category distinction, first class, second class, pass, back and failed, the distinction is having more importance than the failed one. Just by observing this category we can easily say, right? So where order plays an important role, this all the stuff it is coming inside the ordinal data. Is it clear? This is about the qualitative. I am talking about the qualitative data. So qualitative data is having two part, nominal data and ordinal data. In nominal data the order is not important. In ordinal data, order plays an important role. And order, or just mostly ordinal data, it comes in your multivariable category, like distinction, first class, second class, pass class, then some persons are having back and some are failed. Is it clear about the qualitative data? Are you having any issue? Yes.
No, sir, it's clear.
Okay. Now we are moving toward the next part, that is a quantitative data. Now just this is a little bit tricky for understanding purpose. What is a qualitative data? What is a quantitative data? The moment we are measuring something, that is going inside the quantitative data. But now what happens, the student, they are trying to compare this quantitative data with the data types which they learn. That is, they are comparing it with the integer part, they are comparing it with the float part in this way. So it is having some different, what you can say, weightage based on these two different class. One is called as a interval data, another one is called as a ratio data. The example for interval data they have given as a temperature, right? Just will try to understand what is the meaning of this interval data. Just currently, right, as we are living in Pune, right, just try to understand the person who is living in Pune and the person who is living in Himachal Pradesh. So for Pune person, right, we have the normal temperature which is around, what you can say, 25 to 30 in this range. Okay, right? And for the person who is living in Himachal, they have the temperature in the range of, what you can say, 0 to 5 in this way. If the person who is from Himachal, he comes to the Pune, with that person, is the 25 and 30 degrees the normal temperature for that person? Yes. The person who is living in Himachal Pradesh, who is living in cold area, for that 25 to 30% is a normal temperature? No, for him it is what? Hotter one. Yes or no? Right? So in this way, what we can say,
Whatever it will be hotter.
is it right? The person from Himachal Pradesh who is living in the temperature 0 to 5 degree, if he comes to the Pune, for him this 25 to 30 degree is a hotter one. And the person who is from Pune, if you go to the Himachal Pradesh, for that this is colder one. Very, very cold, we can say in that way. So in case of interval data, basically it is said that it is subjective one. It is having a nature as subjective. Means what? Person to person, the nature is get changed. Person to person, the nature is get changed. Clear? Eh? Is it clear? Okay. Is it clear? Okay. And it is not having a, or without zero value. Means what if I am considering a 0 degree Celsius? Is it 0 degree Celsius means no temperature? 0 degree Celsius means no temperature? No, it's not like that. 0 degree Celsius is having a value. It is what? It is having a value. Is it clear? ठीक है. Why I am giving this example? Just now we'll see the second data type, then you can understand. In interval data, again important part, as it is there, means this part is there as it is in your syllabus also, and in the concept of data science they provided this concept as it is, the qualitative data and the quantitative data. Qualitative data is easy to explain, nominal and ordinal data, but in quantitative data they made two part, one is a interval data and another one is a ratio data. Okay, okay, just a moment, I will make a separate slide for that. So inside that we have two data, one is what, interval data, and second is the ratio data. Just try to understand these two concepts. The interval data, it is having non-zero value. Non-zero value, what it means basically, just now I have given you the example of temperature. 0 degree Celsius is having some value. Now in case of ratio, if you go in case of ratio, it is having a zero value. What is the meaning of zero value? Now just consider the example of what you can say rupees or money. You can say it as a rupees or money. If I will say I have a 0 rupees, what it means? I have 0 rupees with me. What it means? Am I having something with me or I have nothing with me? So when we are saying a 0 rupees, it means
You
that
won't have anything.
I don't have anything. So it is having a zero value associated with it. And it is objective one. It is not a subjective. Means what? The person, if he belongs to Pune or he belongs to Himachal Pradesh, for both the person 0 rupees means 0 rupees. For both the person 100 rupees means 100 rupees. Is it subjective? For Pune person 100 rupees is having some different value, and for Himachal Pradesh person 100 rupees is having some different value. No, the 100 rupees means same value, right? So that's why they are, this come in the category of ratio. And the second one, interval. For interval I have given you the example of temperature. Now you can consider the same thing. For Pune person the temperature is different, and for Himachal Pradesh person the temperature range is different, and because of that the Pune person may feel that is a colder one. The Pune whatever the temperature available for Himachal Pradesh, and for Himachal Pradesh person he may feel that that is a hot one. Is it clear? So for interval type we have what you can say non-zero value. Here we have the zero value, and here here we have no zero values. Means we have what you can say the zero value is having an importance, but here we have the zero values in this case. So here we are having it as a subjective one. Person to person things are get changed, and here we have it as a objective ones. There we don't have any concept of a subjective in case of a ratio. Is it clear? These two concepts, both the concepts are for what? They are dealing with quantitative data, where we are measuring the data. Now it is different. Quantitative data, most of the time we are seeing it as we have it as integer data, or we have it as a float data. This is there. This way we will see later on when we will go for the next part of this unit. But initially when they are talking about the different data which they are using, so when they are considering a quantitative data, the quantitative data might be the interval data or it might be the ratio data based on these two parameters. One is if it is subjective, and if it is having no zero value, means 0 degree Celsius means no temperature. No, it's not the case. 0 degree Celsius means we have certain temperature. So if it is satisfying both this category or both this what you can say concepts, both this criteria, then it is considered as an interval data. And if we are going for ratio, in ratio we have a zero values, as well as it is an objective type of data. It is not a subjective one. So these are the two categories available with this. Is it clear? Yes. Yes. Can we go ahead?
Yeah, so we can go ahead.
Yeah. So just understand these two types, right? Related with the different types of data. So we have a qualitative data, we have a quantitative data. In qualitative we have nominal data and we have ordinal data. Nominal mean order is not important, And in ordinal data, order is important. And the ordinal data, it comes in a multivariable, and nominal data, you may be having it as a multivariable or you may have it as a univariable. Next is a quantitative data. Here we are talking about the quantitative. Here we don't have any quantity. We have it as a quality, means everything is acting as a categorical data, and here we have it as a quantity. So we have a numbers here. These numbers we are having in two types, interval data and ratio data. Interval data, we have a, what you can say, without a true zero value there, and we have it as a subjective one. And in ratio data, we have a meaningful zero value, and it is what, objective one. So in this way, we have this two, what you can say, data types. Is it clear? Right, now we'll go for our next part. So now, why they made this distribution, why we require this distribution? So actually this part we will see in I think unit number 2, where we are dealing with most of the statistical part. Okay, na? In that case we'll see this, but now here, as the word is there, we should understand it. So in mathematical operations, so when we are talking about the nominal data, so that is there we are going to count, and in nominal data, basically these operations we are going to perform. That is a mode operation. Then we can go for proportion, we can go for frequency, and we can go for percentage. What is the meaning of mode? Anyone have heard this word mode before this? Yes. Suppose I am considering in whatever the IT, suppose I am considering IT branch. IT branch is having total 25 males and it is having total 25 females. Okay, or what you can say, 26 males and we'll do it as a 24 females. So what mode will do? Mode means nothing but a majority. It deals with so this is one of the type of operation which we are having when we are dealing with the statistics. So mode will consider the majority part. So who is having majority here? As male is 26 and female is 24, so it will give the attention to whom? It will give the attention to the male over here. So that is a mode. Next we are talking about a proportion. So proportion, can you calculate the proportion of male and female from this data? Male का proportion कितना आएगा? Male will be what? 26 upon 50 and female will be what? 24 upon 50. So here I will get a proportion. Frequency is already given. Male का 26 है, female का 24 है, and we also calculate their percentage by multiplying the proportion by 100. We will get the percentage. So these different operations we can perform on the nominal data. Is it clear? Okay. Now when we are talking about the ordinal data, the things are get changed. In ordinal, order is important. Rank we can consider as a, it is important one. And because of that, whatever the parameters are available in nominal, all are there as it is. Here some important parameters are get added. That is nothing but a median. Anyone is having any idea about median? Actually we have to see in unit number 2 where we have to deal with mode, median and mean. Anyone knows about median? किसको कहते हैं median? मीडियन और मीन में क्या डिफरेंस होता है? यस, mean means average. Okay, now we are going we'll see about ordinal. So median means arrange your data in ascending order. Whatever the data we have, arrange it in the ascending order and select the medial value. Select the medial value, that is median. We'll see its example when we'll go in unit number 2. Right now simply understand it. You have to arrange the data in ascending order and select the medial value. That is nothing but the median. Okay, so this one parameter is get added over your, what you can say, nominal data. Rest all things are as it is, which is there for nominal. The same description or same statistics you can use it for ordinal one. Okay, now we are talking about the interval. So when we are going for interval, it's possible to perform both this operation, addition as well as the subtraction here, and because of addition subtraction they have this new terminology which is nothing but mean. They also have the new terminology which is a variance and the standard deviation as well as a range. So this all this part we'll see when we'll go for unit number 2 where we have to deal with the statistics part. And lastly we have the ratio, which is most preferred. In the ratio we have addition, subtraction as well as multiplication and division operation. So here we are having, what you can say, ratio of the numbers. Right, this one important parameter which is added than your interval. So at the end, most preferred data type, the types of data is the ratio one. Okay, and least preferred is a nominal data. So when we are talking about the data, we must know all this part. Depend on these types of data, we are going to perform a different statistical, what you can say, operations on that data. Is it clear? Yes, is there any issue with this? Yes, are you there?
Yeah, sir, it's clear. You can move ahead.
So I think yeah, today we'll stop here. Okay, the remaining part we'll see in the next class related with this thing. So what we covered up to this part, okay, that will I will revise this part. So we started with this part. So up to this part, we covered about the defining the data science and the big data, and we covered the recognizing the different types of data. These two parts we covered here. So data science, what is the definition of data science? If you want to say, it is an interdisciplinary field that uses the scientific methods, algorithms to extract the knowledge and insights from the structured and unstructured data. And for what purpose we are using this? We are using this at the end to perform certain decision. That is the use of data science. So it is a multidisciplinary action we have. Then we consider about the big data. Big data with respect to what we are considering as a big data. Big data, it is dealing with the 3V. One is about volume, one is about, second one is velocity, third one is a variety, or we can say it as a complexity. So these three parameters are available with the big data. Because of that, it becomes expensive to deal with the big data, and it also becomes a little bit difficult to manage the big data. So we have certain tools, advanced tools to deal with the big data. So which different tools we have? So for distributed computing, we have Hadoop, Apache Spark, Apache Flink. These are the three most common tools which we are using for distribution purpose, distributed computing purpose. Then for data storage and management purpose, we have NoSQL, we have Amazon S3, we have Google BigQuery, as well as we are also having SQL for our structured data. Then for data pre-processing and analysis purpose, we have Apache Kafka. We also have the TensorFlow, as well as we have new directory, which is a DAS directory. And for visualization perspective, for big data, either we can go for Tableau or we can go for Power BI, which is from Microsoft. And the one of the new library which is available, which is related with what you can say, Plotly, that is related with the data frame which we are using. And lastly, we covered about the different types of data we have it. So we covered that, we divided it in two parts. One is a qualitative, another one is a quantitative. In qualitative, we have nominal data, ordinal data. In nominal data, order is not important, like male female. In ordinal data, order is important, like first class, distinction, second class, like that. In quantitative data, we have two types. One is the interval data and the ratio data. The example of interval data is nothing but the temperature. So temperature is what? It is having a no zero value, and it is a subjective to the person. And ratio data, it is having a meaningful zero value. The example which you can give it as a money, which is having a objective nature. Okay. And at the last, we cover the different operations, statistical operations, which we can perform on nominal data, ordinal data, interval data, and the ratio data. So this is the part available for unit number 1 up to this point. In the next class, we will start with the different processes available for data science and how to deal with these different processes. Anyone is having any issue, any doubt? If you have, you can ask me so that we can clear it. Yes, कुछ डाउट है, कुछ आपको समझना है, you can ask me, there is no issue. Other than lecture also, if you have any doubt, you can ask me. It's Pranav saying, sir, I have got some doubts regarding. Oh, I have some doubts regarding quantitative field. May I have your personal contact? I have, okay. I am already there in a group. I will share my contact on a group. Okay. I want to enter the quantitative research field. Okay, good one, Pranav. Yes, I will share that on a group. Okay, jam file with the meeting. Okay. Sorry, Bharat. I was just now. I have seen your message. I will check that stuff from the next part. I will write everything on that Jamboard. Okay. Okay. Anyone is having any doubt? Okay, then if you don't have any doubt, we'll stop here. Okay. So we'll meet tomorrow. It's not possible to have a lecture. We'll try to take the lecture. Are you there? Yes, Pranav, I am there on a group. Yes, I will share my number. Okay, as well as this presentation I will also share on our group. Okay, na? There's no issue. Tejas, actually just what again, on Friday I came to know about this event. So I don't know because I just heard it is an honor subject. I don't know what is the structure of honor subject and all this stuff. You can ask your respective teacher; they can give more idea regarding that. Okay, yeah. Okay, then we'll meet mostly on tomorrow. It's not possible, so mostly on Wednesday we'll try to meet. I think I heard that in first week of September you have your INSEM exam. Before that we have to complete two units. So we'll try to take lectures and we'll try to complete our syllabus at least for first unit. So for first unit we'll try to take it on online, and after your INSEM exam we'll see if possible we'll go for offline lectures also. Okay. Yes, chalo. So thank you so much. Okay. Take care. Good evening. Bye. Yeah, Prano, I also want the same thing, but just we have to, because in online mode, I also feel that it becomes little bit difficult for me also. Are you getting something or you are not getting? So for me also it becomes difficult, but still we don't have any option. That's why we are going in that way. We'll try to discuss with sir, madam, and then we'll try to arrange it in the offline way also. There is no issue. Okay. ठीक है चलो. Yes. Okay. चलो. Bye bye. Take care. Good day. Bye.